let's do this thing. So this is our 10.2 notes. We're going to talk about wave phenomena. Does anybody know what that means? Phenomenon? Anybody?
I just think of the Muppets.
Cool things that happen. Okay? Cool things that happen because of waves. So the first thing that we're going to talk about is the Doppler effect, which is what that video was that I just showed. First bullet, when the source of a wave is moving, the wave's frequency can change. Okay, so like that car that's moving, its frequency can change. When the source of a wave is moving, the wave's frequency can change. This change in frequency is called the Doppler effect. Okay, that's why you think of, like whenever an ambulance passes you, it sounds different behind you, and whenever it passes you, and whenever it's in front of you. Okay, that's because of the Doppler effect and that frequency of waves. With sound waves, we hear different frequencies as different pitches. So high pitches, low pitches, things like that. Okay, and it's just based on our ears receiving those waves. All right, so let's talk about when sound is moving towards us and when sound is moving away from us on this next little portion of our PowerPoint here. Okay, so wave sources moving towards you. So whenever you are here, okay, we're going to talk about what it sounds like when this guy is coming at you right here. All right, wave sources moving towards you. The waves are going to get bunched up. Okay, so you can tell that they're a lot closer together right here than they are after, whenever they're going away from you. And it's going to result in a higher frequency, which in turn is a higher pitch. Y'all with me so far? Okay. So that's moving towards you. Now, this fire truck has passed you and it's moving away from you. Our waves are more spread out. Okay, waves get spread out. What kind of frequency are we going to have now? A lower frequency. Okay, so they're going to hit your eardrum at a slower pace, a lower frequency. Okay, that's the Doppler effect in a nutshell. Are we okay with the Doppler effect? That's why things sound weird when they pass you. Got it? All right, let's talk about more parts of waves. So we talked about crests, troughs, and the rest position and wavelength last week. We're going to add amplitude today. Okay? So amplitude. All amplitude is the height of a wave from rest position to crest. So amplitude is how tall your wave is. The height of a wave from rest position to crest. Okay, so this one is a taller wave than this wave, so it has a higher amplitude. Okay, the unit that we use for amplitude is going to be meters because it's measuring like a distance, it's measuring height. The same as wavelength, okay, meters with a lowercase m. Okay, this next thing, this wave interference that we're about to talk about is what your assignment is actually going to be about today. Okay, so we talked about Doppler effect, we've talked about amplitude. Now let's see what happens whenever waves collide with each other. Okay, that's called wave interference, the interaction between multiple waves. The interaction between multiple waves. And then on the picture, I just draw two separate waves. That way you know that's talking about two waves coming in contact. So what we need to know about wave interference is that there's two ways it can happen. Okay, and we're going to go back and talk about crests and troughs to understand how these two ways happen. Okay, two types of interference. Waves interfere in one of these ways depending on how they line up. Okay, so before we write anything down, we have constructive interference and destructive interference. Can somebody tell me like what you see is the same or different between these two pictures? They're the same colors, okay. What about how they're lined up? let's talk about these interfering waves right here. The top ones are the same. Okay, on this bottom one, the crests are in line and the troughs are in line. Do y'all see that? Okay, so this is a crest and this is a crest and they're in line with each other. Over here, this crest is lined up with this trough. The trough of the red line is lined up with the crest of the blue line. Do y'all see that now? Okay, that's the main difference. Whenever we have constructive interference, maybe, when they line up crest to crest or trough to trough, they are going to add to each other's amplitude. Remember, amplitude is how tall a wave is. So, these two waves interfere with each other. Whenever they collide, they're going to create this one wave. And it's taller. It has a higher amplitude because whenever they are constructive, whenever they line up this way, they just make each other bigger. Okay? On the other hand, we have destructive interference. So when you think of something that's destructive, it like tears things apart, right? That's exactly what this does. Whenever waves line up crest to trough, like we talked about, they're going to subtract from each other's amplitude, and sometimes that results in a canceled out wave, a straight line. Okay? It destroys those waves, and it makes it a straight line. That's how I remember it. Destructive, destroys, things like that. So what you're going to have to do is, like on your assignment today, it's going to give you one of these pictures or one of these pictures, and you have to decide, is it constructive or destructive, and what the resulting wave would be. But we're going to get some practice on that in just a second. All right, all kinds of waves can interfere, including sound and light waves. So this is going to be true for all types of waves. It's not just sound, it's not just light. Okay? Any type of wave can interfere. Interference creates bright/dark or loud/soft spots, depending on if you're talking about sound or light. Okay, so with light, if we have constructive interference and the amplitude just increases, we're going to look at something that's really, really bright. If we look at destructive interference for light and it cancels out, we're going to be looking at something that's really, really dark. Okay? It's going to go the same with sound. If it's constructive, we're going to have super loud sounds. If it's destructive and that wave gets destroyed, we're going to have really soft, quiet sounds. Does that part make sense? Okay? Let's go ahead and practice how we draw this wave interference. Okay, so first of all, this is going to be exactly what your assignment is like. So if you have questions while I do this, please ask me. Okay? When we look at these, the first thing we need to decide, is this going to be constructive, where we add to our amplitude, or destructive, where we flatline it? What do y'all think just by looking at this? Constructive or destructive? I would say it's constructive as well. Okay? And that's because, so constructive is whenever the crests line up. So this crest is at 1, this crest is at 1. Okay, so they're lining up in that way. So it's going to be constructive. Go ahead and make a note somewhere on that paper that this is constructive interference. So when we have constructive, we're going to add to our amplitude. So these two waves are going to combine and create a big wave. Okay? And there's a tiny bit of math involved. Okay? So these crests on this one are at 1. Does everybody see that? 1, 2, 3, 4. They're at 1. The crests on this wave are at what? 2. So where do you think the crests on our combined wave should be? 3. Okay? So our combined crests over here need to be at 3 and -3 for our troughs. Okay? Because they're going to combine and make it bigger. What's up?
So when one's destructive, just the first thing that goes on resident is just going to be fluid. That's how you know it's destructive.
Yeah, pretty much. So if this was a trough instead of a crest right here, it would be destructive. Okay, so now this is what I like to do is I will go, because we want to keep our wave on the same points. So I'm going to go and put little pinpoints of where my crest and trough should be. So my crests are always on, so 1, 3, 5, that's a joke. 1, 5, and 9. So 1 is going to be a crest, 5 is going to be a crest, and 9 is going to be a crest. Okay, and that's just if we were to number these things. My troughs are at 3 and 5 on both of these, 3 and 5. So my trough is going to be at 3, and 7, my bad, 3 and 7. Once I have my points, I can draw my wave. It doesn't have to be perfect, it just needs to hit your points. So that is how we would draw that constructive interference with these two waves. Does that make sense to you guys? Okay. Your assignment today is 3 of these. Okay, so you're just going to have to draw 3 graphs based on is it constructive or destructive. Now, if it's destructive, what are you going to draw? What kind of line are you going to draw? If it's, I know what you mean, but listen to my question. What would you draw here if it's destructive?
It'd be short.
It would be a straight line. Okay? If it's destructive, it's going to be a straight line because it destroys the waves. Does that make sense? Okay? Constructive, you're going to have some wave thing happening. Destructive, it's going to be a straight line. Does that make sense? On your assignment, there are like little questions in between, and I know you're going to miss them, but that's why I'm bringing them up. So it gives you your 2 graphs, and then it asks, is this an example of constructive or destructive? I just want you to circle, is it constructive or destructive on all of these? Does that make sense? Don't forget to do that part of your assignment. Sound good? Do we have any questions? Okay, if you do have questions while doing the assignment, please ask.